So this is problem 31 of chapter 8 of Giancoli 6th edition. So they give us a figure with a distribution of masses, and they want us to calculate the moment of inertia of this array of point objects depending on the axis of rotation. So in the part A of this problem, what we have is the following. We have two little masses, which are the values are given to us, and we have two other big masses here, also the values are given to us. And they are connected by some wires that are very light, so we don't really care about the masses of these wires. And now we put the thing to rotate. In this part A, the x of rotation is vertical, and this is our x of the axis of rotation. They tell us the distance of these masses from the x of rotation. This one is 0.50 meters. The other one they don't give it explicitly, but they say that this whole thing is 1.50 meters. So then we know that this distance here is 1 meter. And so with that we are able to find the moment of inertia. What is the moment of inertia? Is the sum of all the masses and their corresponding distance from the axis of rotation. So for part A, what we have is mass m, the little mass m, with away from the axis of rotation by 0.5 meters, so squared. We have the other little mass away by 1 meter squared, and the big mass away by 0.5 meters squared, and the other last big mass away by 1 meter squared. And with this, we will find the moment of inertia. In part B, we still have the same structure of masses connected by wires. So we still have the little m's and the big m's here, still connected by very light wires. But now we are going to change the x of rotation. And now we have the x of rotation placed here right at the middle of the separation between these small and big masses. And this distance, this whole distance here is 0.50 meters. So we know that each one here is 0.25 meters. And again, we'll be able to find the moment of inertia. In this case, it's easier. All of the masses, the distance from all of the masses from the axis of the rotation is 0.25. So I just have to add all of the masses, 2 little m plus 2 big M multiplied by 0.25 squared. Which one is larger? Which moment of inertia is larger? Well, clearly the one on top. This one is larger because we have masses that are placed far away from the center, from the axis of rotation. So because this moment of inertia is larger, we know that it will be more difficult to start accelerating this one. So this is the harder one to rotate.